All right, so here are the negative number identities. All right, and here they are. The cosine of negative x is equal to the cosine of x. The sine of negative x is equal to negative sine of x, and the tangent of negative x is equal to negative times the tangent of x. Okay, and the reciprocals, they follow as well. So the reciprocal of cosine is secant. So the secant of negative x is equal to secant x. The reciprocal of sine is cosecant. So the cosecant of negative x is negative cosecant x. And the reciprocal of tangent is cotangent. So cotangent of negative x is equal to negative cotangent of x. Okay. So these are actually called the negative number identities. And if you remember from college algebra, on some problems you were asked to, write the exponents as positive exponents. So you'd have to take the negative number, make it a positive. So that's the same concept here. We're taking a negative angle and we're making it a positive angle, right? So here's some examples. And I'll start with sine. So let's say I have the sine of negative 30 degrees, right? Using this formula here, I can actually write negative 30 degrees as a positive angle. So if I use a formula, that should equal to negative times the sine of 30 degrees. Okay. So what I've actually done here was I've expressed a negative angle as a positive angle. So let's take a look at that on the calculator. All right, so I'm going to just make sure that I am in degree mode. So if I were to put in the sine of negative 30, right, I get negative 0.5. That's the same thing as negative times the sine of positive 30 degrees, right? You can see that they're one and the same. Tangent is the same way. So let's say the tangent of, and I'll just use negative 30 and 30 degrees. So if I were to put in the tangent of negative 30 degrees, right, I get negative 0.57. That should equal to negative times the tangent of positive 30 degrees, right? So I put in a negative times the tangent of 30 degrees, right? We have the same value. And the same thing are true for the reciprocals, the cosecant and the cotangent. All right. Now, what may not be so clear is this first one. The cosine of negative x is equal to the cosine of x, right? It means you could just basically change a negative angle to a positive angle and vice versa. So if I have the cosine of negative 30 degrees, that should equal to the cosine of positive 30 degrees. All right, so let's check that out in the calculator. So we have the cosine for negative 30 degrees is 0.86. Should be same thing as the cosine of positive 30 degrees. All right, and these are called the negative number identities. All right, so let's take a look at an example. X sine x is equal to 4.5, and we're asked to find negative x sine of negative x. All right, so we have x sine x is equal to 4.5, and we're asked to find negative x times the sine of negative x. All right, so the first thing I'm going to do is I'm going to write negative x times the sine of negative x. And I'm going to rewrite that negative angle as a positive angle by using this formula. Right? The sine of negative x is equal to negative times the sine of x. So this is equal to negative x, right, which I have in the front, times negative times the sine of positive x. Now, based on the rules for sines, a negative times a negative is a positive. So this actually equals to x times the sine of x, right? And x times the sine of x is equal to 4.5. All right, and that's using the negative number identity. All right, next we're going to take a look at this example. Okay, and this has to do with inverse functions. The cosine of the arc sine of 1 over x. All right, we're asked to evaluate. All right, and based on the, hopefully you watched the inverse trigonometric function video. All right, so in this chapter 9 where it says inverse functions, I'm just going to bring that up briefly. So notice here we have the chart, and notice that in the first column of the chart we had a function, and in the third column, right, these are the most two important columns, we have the intervals, right, the intervals in which the inverse functions lie. So for example, the arc sine lies in between negative pi over 2 and pi over 2. The arc cosine lies between 0 and pi. The arc tangent lies between negative pi over 2 and pi over 2. The arc cotangent lies between 0 and pi. The arc secant lies in between 0 and pi. And then lastly, the arc cosecant lies between negative pi over 2 and pi over 2. All right, so let's take a look at this problem. All right, so just as in any branch of mathematics, we're going to work it from the inside out. And then for this, we're going to have to do what's called a triangle sketch. So the first thing I want to do is I want to start with the arc sine of 1 over x. So keep in mind that the arc sine is found in between negative pi over 2 and pi over 2. So if we were looking at a unit circle, this is negative pi over 2, and this is positive pi over 2. So we're looking for an angle that will lie either in the first or the fourth quadrant. All right. So based on that reference angle chart, we have all students take courses. Well, if the sine is in the first quadrant, if the arc sine is in the first quadrant, it has to be positive. And if the arc sine is in the fourth quadrant, it would have to be negative. So since our arc sine is positive, 1 over x, we're going to assume, or we're going to know that it's in the first quadrant. All right, so we're going to sketch that out in the first quadrant. All right, so this is our first quadrant. Okay, and I'm just going to arbitrarily draw a triangle. Right. Well, first I'm starting off by drawing an angle. Right, in the first quadrant, I'm going to drop a perpendicular. And I believe my pen is going dead. I'm going to drop a perpendicular. All right, we have X, Y, and R. All right, so we're given that the arc sine is 1 over x. So that actually means that the sine is 1 over x. So the arc sine is equal to 1 over x. So notice from our trig functions, the sine is y over r. Right? So from this, we can conclude that y is 1 and r is x. Right? So this is our angle measure theta always. Now, also from our 6 trig functions, we had the cosine is x over r, the tangent is y over x, right? The reciprocal of sine is cosecant, that's r over y. The reciprocal of cosine is secant, that's r over x. And the reciprocal of tangent is cotangent, and that's x over y. Right? And we also had the Pythagorean Theorem. R is equal to the square root of x squared plus y squared. X is equal to the square root of r squared minus y squared. And y is equal to the square root of r squared minus x squared. So we want to find x. So I'm going to use this formula, the square root of r squared minus y squared. So that's the square root of r, which is x. I'm going to square that, plus y squared. So y squared is 1. 1 squared is 1. So we have the square root of x squared minus 1. Right? Because in that form it's r squared minus r squared minus y squared. Right? So we've constructed a triangle based on the arc sine of 1 over x. Right? So we've simplified the inside. Now we're going to simplify the outermost, the cosine. So remember that the cosine is x over r. So if I wanted to find the cosine of theta, I'm going to take the x value, which is the square root of x squared minus 1, divided by r, which is x. And we have y is equal to the cosine of the arcs. Okay, that's the wrong. We just did that one. Okay, f of x is equal to 2 cosine 1/3 x minus 3 halves pi minus 3. we have to find the amplitude, the period, the phase shift, and the vertical shift. Okay, so that's f of x is equal to 2 cosine 1/3 x minus 3/2 pi minus 3, and we're asked to find the following. And I'm just going to write above this. So the form of our trig equation would be f of x is equal to a, in this case, times the cosine of b x minus c, and then plus d. All right, so this is the form of our equation, and the amplitude, that's equal to the absolute value of a. All right, so a is going to be 2. All right. Next, we're asked to find the period, and the period has a formula. The period for the cosine, sine, cosecant, and secant we have is 2 pi over b. All right. So notice that we have b, that's going to be the coefficient of x. So we have 2 pi divided by 1/3. Right. So if I change the numerator to a fraction, I'm going to have 2 pi over 1, right? Because 2 pi over 1 is 2 pi, divided by 1/3. And then I can multiply the very top and the very bottom. So 2 pi times 3 is 6 pi. I can multiply the bottom of the top and the top of the bottom. So 1 times 1 is 1. So I get my period as 6 pi. Next, we have the phase shift. And the phase shift also has a formula. It's C over B. Right. So if I take a look at C, that's going to be 3/2 pi, and B is going to be the coefficient of x, which is 1/3. So I'm going to set this equal to 3/2 pi divided by 1/3. And I want to do the same thing. I'm going to multiply the very top and the very bottom. 3 times 3 is 9. I'm going to multiply the bottom of the top and the top of the bottom. 2 times 1 is 2. And I'm going to attach pi. So the phase shift is 9/2 pi. And then lastly, we're going to look at the vertical shift. And the vertical shift, that's equal to d. So notice in our formulation, d is going to equal to -3. So we have -3 as the phase shift. All right. So let's see, is there anything else we want to cover? And there is one more I want to cover. So I'm going to pause it. All right, so in this problem, we're asked to give the amplitude, the period, the midline, and we're asked to find the equation. All right. So first off, before we begin, we have two choices. We could either use a sine curve or the cosine curve. Now, depending upon which curve you use, there is no right or wrong. I mean, because a cosine curve is basically a sine curve shifted 90 degrees, and then vice versa. But what I'm finding from this particular textbook is that they're modeling everything using the sine function. So I just want to look at the sine function for just 1 second. All right, so here is the graph of the sine function. And since we're modeling the sine function, just notice the characteristics of a sine function. Okay, this sine function, it starts at the origin, and then it rises toward the first peak. All right, so we're going to use that as far as the sine formulation for our curve. All right, so first we're asked to find the amplitude. So keep in mind that the amplitude is the overall height of our curve. So here's the formula for the amplitude. It's the max value minus the minimum value divided by 2. Right, so we can see that our max value is 3 minus our minimum value, which is -5, divided by 2. So we have 8 over 2, which is 4. So our amplitude is 4. Right, so it's the maximum minus the minimum divided by 2. Next, we're going to find the period. Right, and the period is the amount of time it takes to make one complete rotation. All right, so in this case, we're going from peak to peak. And one thing I want you to notice about the graph is that it's not actually going by one. So each tick mark, so if I look on the x-axis, I have 1, 2, 3, 4, and 4 makes actually 1 unit. All right. So let's count this out. So we have 1, 2, 3, 4. That's 1 unit. 1, 2, 3, 4. That's 2 units. So our period is 2 units long. Now, in the model form that we're using y is equal to a times the sine of bx minus c plus d. Right, so when we write out our formula in the end, we must know a, b, c, and d. All right, so we know what a is, right? The amplitude, right? That's the absolute value of a, so we know that a is 4. I'm going to use the period to find b. So keep in mind that the period has a formula 2 pi over b. And we know that the period is 2, right? We just calculated that. So 2 is equal to 2 pi over b. And I'm going to solve it for b. So I'm going to multiply both sides by b. I'm going to divide both sides by 2. So b is equal to pi. All right, based off the period being 2. Next, we're going to find the midline. The midline is also d. So let's find the midline, which is also d. So that's equal to the max value plus the minimum value divided by 2. So again, the max was 3. The minimum was -5 divided by 2. All right, so we have the midline, which is d, is equal to -1. Right, so our midline is -1. And next we're asked to write the equation. So we know A, we know B, and we know D. Now we must find C. And in order to find C, we're going to use the phase shift formula. Okay, and I'm going to do that here. So the phase shift, and remember that the phase shift is the horizontal shift on a curve. The phase shift is equal to C over B. We've already found that B was equal to pi, and we're going to physically calculate the phase shift. So notice that the midline is 1. So this graph is actually shifted over a half a unit, right? Because remember from that sine curve, right, it starts and then it rises toward the first peak. Right, so notice that we have a phase shift. So notice we have 1 tick mark, 2 tick marks, but 4 makes 1 whole unit. So our phase shift is actually 1/2, right? It was shifted over 1/2 units from the y-axis. So our phase shift is 1/2. So I'm going to substitute all of this into this phase shift formula to find C. So we have the phase shift, which is 1/2. That's equal to C over pi. I'm going to multiply both sides by pi. So I have 1/2 pi is equal to C. So now we can write out our formula. So we're going to write this out as f of x is equal to 4 times the sine of pi times x minus 1/2 pi. So now keep in mind that this minus comes from our formula. So that has to be a minus. Even though when we calculate it, we got a positive 1/2 pi. Our formula makes it negative minus 1. All right, so this is the formula for this graph.